So over here the question is saying figure given below shows a rod PQ of length 20 centimeter and mass 200 gram suspended through a fixed point O by two threads of length 20 centimeter each. A magnetic field of 0.5 Tesla exists in the vicinity of the wire PQ as shown in the figure. The wire connecting PQ with the battery are loose and exert no force on PQ. Find the tension in the thread when the switch is open. A current of 2 ampere is established when the switch is closed. Find the tension in the thread now. So if we begin with this problem, the first thing that we say is when the switch is open there is no current flowing through it, so there is no case of dealing with magnetic force. So in the first part of the problem we are only balancing the weight of the rod, and the next part which we are clear with is since the length of the rod and the rope, that is the thread, are of equal length, so it is forming an equilateral triangle, that is the angle of the triangle is going to be 60 degree. So if I draw the FBD for this without the current being switched on, so there is no current going on, so I say that this is the rod which we have, and it is exerting a force in the downward direction which is equal to weight mg. Now over here if I draw the direction of forces which the thread is going to exert, so we are saying that the thread is exerting a tensional force T and a tensional force T like this from both the ends, and since the diagram is symmetric the tension from both the end is going to be same. Now over here I am saying that since it is an example of an equilateral triangle, that is each side is 20 centimeter, so each angle is 60 degree, and hence I say that this can be 30 and this can be 30, that is by drawing an angle bisector line by symmetry. So I say that this is making an angle of 30 degree with the vertical, and so is this thread which is making an angle of 30 degree with the vertical. So if we break the component of the thread in the perpendicular direction, that is somewhat like this, that is y-axis direction, so we get t cos 30, and over here also we get t cos 30. So t cos 30, and over here also we get t cos 30, and hence I say that the weight in the upward direction, that is 2t cos 30, is balancing the weight which is mg in the downward direction, and hence the tension can be calculated as mg upon 2 cos 30 degree. So over here if we start substituting the value, so the mass is 200 gram, that is we can put it as 200 by 1000 in kg. G we are taking it as 9.8 by 2, and cos theta is equal to root 3 by 2. So from here we obtain the expression of tension as 1.13 Newton. So over here we obtain this expression that is equal to 1.13 Newton. Now in the second part the question is saying that a current of 2 ampere is established when the switch is closed. So after closing the switch, if the current of 2 ampere is established, then in this FBD we are making some changes. So apart from this, the magnetic field being pointing in the outward direction, so the magnetic field is pointing in the outward direction, and the current which this rod is carrying is in this direction. So this is the direction of current which we have. The magnetic field is in the outward direction, that is pointing outside the screen. So again if you use the left hand rule, so kindly align your left hand, that is your index finger is pointing outward from the plane of the screen, your middle finger is pointing towards your right, that is in the direction of current. So you will see that your thumb is pointing in the direction of mg. So if it is so, I can say that the magnetic force which is going to act in the downward direction, and this time we have F magnetic which is equal to ILB, which is going to act along with the mass mg when the current is switched on. So we just have to make necessary changes with this expression. So the necessary change which we are making is we are writing 2t cos 30 is balancing mg plus ilb. So we are writing this time the expression is changed to 2t cos 30 is this time balancing the weight, that is mg. Along with this it is also balancing ilb. So in the problem the values are given to us, so we put over here the 2t cos 30, that is root 3 by 2, is equal to mg. So the mass is 200, that is 200 by 1000 into 9.8. So now it is carrying a current of 2 ampere having a length of 20 centimeter and magnetic field 0.5 Tesla. So we write it as I is 2, L is 20 and B is half Tesla. So this is going to be the expression which we are going to be reduced with, and on calculation from here we obtain T as 1.25 Newton. So this is going to be our answer for this particular problem.